You did not
Please
sleep.
give me a
Got stuck on the couch. It's funny.
I had to sleep on the couch. And I got hand sanitizer. The smell of hand sanitizer in my throat.
That's no fun.
Mom.
There we go.
Does anyone like snack in here?
I do. I have that one over there that I have. So sometimes with my lupus, my hands get like my joints start to hurt, and that feels good. Like I can work my hands with it and kind of keep them moving.
Is it
And
a cloud dough?
it's a cloud slime. Yeah.
Oh my God.
It has axolotls in it. It's called axolotl cloud, and it has a little. There's a tiny little. I'll show you. There's a tiny little axolotl in it, and then there's a little cloud, like sprinkle things.
I've never ever felt a cloud dough. Ever.
See a little axolotl in it.
Oh my God, that looks like the one from a YouTuber I know called Peachy.
Yeah. Oh yeah, yeah. Peach babies. Yeah.
You heard of it?
I have heard that. So this is like.
I've never felt one.
Yeah, and so this is from Slime Obsidian. So all of their slimes have like a theme, and then they all have a scent. I think it's peach gummy ring.
Oh,
Right?
smells good.
Yeah, so they've got all kinds of them, and they're really fun looking. I want to get one of the ones, they have some with like little foam cubes in them.
Jelly cubes.
Yes, the one they
Oh my
sizzle
God.
when you squeeze them. And I want the sizzle.
I have my own homemade jelly cubes.
Do you?
I have millions of homemade.
Do you really?
I have 2 Peachy babies.
All right.
And I really want another slime from a YouTuber that I know called Snoop Slimes.
Snoop Slimes. I don't know that one. It sounds cool though.
Yes, but I'm missing. I have Bingzu and jelly cubes. I have butter.
Butter.
I'm just missing icy.
Ice slime. Cloud.
Cloud.
Yeah, there you go.
Nice.
That's really kind of cool. I like it. But it helps my hands when they're sore.
Also, cloud dough is the slime that you stretch and then you pour it.
Yeah, it kind of strings.
Uh-huh.
It's interesting. It doesn't pour, it kind of, I don't know how to describe it. It's weird. Yeah, yeah,
I
yeah.
just need like fake snow, not like plastic snow, fake snow and water, and then I'll make.
Then you'll have everything you need to do it. Yeah.
My mom won't buy me any more Peachy babies.
Oh, yeah, they're expensive. That was an expensive one, but I was like, I'm gonna get myself one that I'll enjoy because it smells nice. It doesn't smell like glue, you know. Some of them just straight smell like glue.
There's only one slime that I have that smells great,
Hmm.
and it is my Peachy baby slime.
Yeah.
The second one I got. It's called De-Stress Dough.
Oh, de-stress dough. Okay.
It smells like water.
Yeah, the slime obsidian. Whoop. This is where I got it. But they've got all kinds of like,
Mystery slime? What's a mystery slime?
you don't know until you get it, but like they've got the icy ones and they've got, okay, yeah.
That's the jelly.
Buttercream.
Oh my God, that's what it is. And there's an icy.
Jelly, fizz.
Pikachu.
Yeah, they got a Pikachu.
There's blood curse.
Blood curse, yeah. Honey jelly.
I don't like.
See this one with the cubes? I like that one. That looks cool. Look at honey butter toast. Purple axolotl, huh?
They're
Yeah.
sold out.
Honey melon boba. Tell ya. Hi.
Emerson and Everly coming.
Yeah, they're in.
Spanish.
They're there in Spanish. They'll be here in a minute.
Baby slime.
Yeah, silly one. There you go. Yeah, they have lots of neat stuff.
You won. Oh, cool.
Pumpkin pie cake pops. Look at that. Banana milk.
It's
Chala.
iced. Oh my god, a polo.
See, they got all kinds of fun stuff, so.
Space Jiggle, oh my god, it's a water slide.
Wait, if you have you seen the Dr. Swift shorts Screaming Goat meme where they blow into the slime and it looks like it's screaming and they put eyeballs?
Yes, yes. Yeah, I've seen that. That is great. Lemon poppy seed, green apple crunch. I'd like a crunchy one.
Yeah, that's-
Mine's not crunchy. Yeah, peach bourbon crunch. Kitty cubes. Cloud nine. Anyway, it's fun. They have fun stuff. If you've got your lab, hang on to your lab for a minute, okay? Because we're gonna talk about labs at the beginning of lab, so you don't have to turn it in. Yet. Though we will be turning it in.
Like, so this is actually like a hat, like rough, like hat. Did you see like in the DMC like where like all the
Yeah.
people from Wisconsin were wearing cheese hats?
Yes, I did. They always do that. It's so fun. That's definitely a Wisconsin thing.
Yeah.
When you do these, write your name on this, on the other side. Because I try not to look at whose names they are. I keep them all just Rico up, so I don't see who did them. That way I'm not biased, right? I can for sure pick. Did everybody have a good weekend? Anybody do anything fun yesterday for Labor Day?
Nope.
Nobody did anything?
Like-
Go out and watch TV all
Oh, did you?
Yeah.
Well, my husband and I went to a winery and then a movie. That was our day.
My
day. What
friend,
was the movie?
It's the Reagan movie, because we heard that Dennis Quaid did a really good Ronald Reagan, and he does a frighteningly good Ronald Reagan. It was amazing. Felt like I was watching my childhood president. It was weird. Yeah.
my friend actually got picked up their new puppy from Ohio.
Oh, really?
It's
What
a
kind of?
Bernedoodle,
Oh
and
my-
when I get to them, I'm gonna ask them a bunch of questions of the puppy, and I'm gonna ask them if they saw stopped by the world's largest apple basket and the wall of gum.
The world's largest what?
Apple basket and the wall
Oh.
of gum.
Where did they go? Ohio? Is that what you said?
There's also a pencil sharpening machine.
Oh, yeah.
Largest chair, world's largest-
Do you like Roadside America? There's a, yeah, that's my,
Oh,
that
that was
cardinal.
not all.
that one's not bald. I have a couple of bald cardinals because they're molting. Sometimes they get mites and they get bald, and sometimes they're molting. And I have several that have been, all summer have been just completely bald, and their skin is black, like tar. And they look really weird when they have no. Well, maybe we get lucky, maybe not. So I have to tell you guys, Saturday night, did you guys get a storm Saturday night? Not everybody got it, but it was really, really strong right here. And so it was a little after 10 and I'm in bed and I had just closed my eyes and I had just started to drift off. You know, when you're like not even aware that you're not awake anymore, you're just drifting off. And then boom, it wasn't just kaboom, it was crack, and it was so bright that I could see the blue-white light through my closed eyelids, y'all. Lightning hit somewhere right out here in the trees. And it took my husband a second, like it was a delay, and his hand comes over and he goes, "Are you okay?" Like, it was so like dang that the both of us just froze. And I went to Drew's room and I'm like, "Are you all right?" And he's like, "That was really loud." I was like, "No, that was legitimately behind the house." So I went out there after church on Sunday and walked, tried to figure out where it was. I think it's one of the trees that my neighbor has right up against their fence, because there's damage to the bark in a straight line. And I think that may be that they also had a lot of construction done, so that maybe somebody scraped it. But it was, y'all, it was the closest lightning strike of my life. It startled me. It was so loud and so bright that I could see blue through my eyes. Like, it was great. You know, like if your eyes are closed and suddenly there's light, like sometimes you see it, but it's a little reddish because you're looking through your skin. No, this was blue. This was like, I was like, anyway, okay. Real quick, hang on to your labs for right now. We're going to talk about lab 4 at the beginning, I mean, lab 3 at the beginning of lab 4 today. And you should have time at the end of today's lab to sit down with your team and make sure that your lab is completed correctly and everything is done. Because I had a lot of people that were like, "Hey, we don't know what to do," or "I don't know what to do." But it was like last night, And that's too late. Like I can't, not much I can do at that point. So, all right, awesome. Okay, no tappy tap because my mom sits right beneath your feet. She's probably down there going like, what is going on? All right, let's start with measuring matter. Y'all get your workout. Be sure you're ready here. Give every minute to get situated. So a lot of this we've talked about already like twice this year. We're talking about it just a little bit more because I want to make sure that you guys are really, really good at this stuff and you really, really understand it because this is essential to chemistry. Yeah.
Miss Mary, did you know the word none is a N doing a cartwheel?
Oh, that makes perfect sense. That actually does make sense. That is funny. None like the Catholic type, right? Yeah, yeah, N-U-N. That's really that. It is an N doing a cartwheel. Okay, that would be fun. I bet there are some nuns that can do good cartwheels too. That would be fun.
At first, when my dad told me that joke, I was like, what?
Mm-hmm. Say it again, Dad. All right. Measuring matter. Here we go. So remember, because we've talked about it more than once already this year. The measurement's important. So why is measurement important? Okay, you've seen this. This was in your first lesson. You stop and think about it. You realize that measurements surround you everywhere and they matter. We measure all kinds of things, even when we don't really think about it as measuring. Like, how long does it take you to get here, Lucy? Oops, hang on.
An hour.
An hour. So that's a way that we measure time in that case, right? So that's a good example. All right, so let's look here. What is that measuring?
Right.
There you go. Very good. And what's that measuring?
Wait.
Mass, usually, or weight. Yep. Okay. And usually we say mass with the triple beam balance because you're balancing the weights over here, but mass and weight are very similar. What's the difference between mass and weight again? What is it?
Mass is the amount of matter in an object. Weight is the measure of the force on gravity on it.
Right. There you go. On that mass. Okay. So what's this one then? This one's weight. Very good. And what's that one? This is a floor plan. Does anybody know? Area. So say you have a house. Well, we'll come back to that one. There's volume, right? What's this?
Density.
Density. We're going to be doing that in lab today. And this one is time. And what's this last one?
Temperature.
Temperature. Very good. Okay. So area. Whoop, I don't know why this is ticking along. It shouldn't. Area real quick. So that's like, say I want to get a rug to go under my table. I need a rug that's maybe 6 feet by 8 feet. That's an area. Right. That's 2 dimensions, right? So area, sorry, is about 2D, 2 dimensions. And that's because it's like length times width. You're only measuring 2 things. Now, if you're measuring volume, like of a cube, it's length times width times height. That's 3 dimensions. We call that 3D. Is the world around us 2D or 3D? 3D. Very good. Yeah. All right. So let's have a look here. What's the name of the system we use here?
International metric system.
In science, we use metric. Yeah. What do we use in the United States? Like, what do we call it?
International system of units.
That's for science. What's the common one that we use kind of every day in the US? Do we know? So it has multiple names. It's imperial, standard, or customary. Give me an example of something in imperial, standard, or customary.
Miles.
Miles. Yeah. What else? What would be another way to do it? Inches.
Pound. LB.
Pounds. Yep. Pints, quarts, tablespoons. Whoops. Why'd that go so fast? But in science and most other countries, Europe uses metric. Europe is smart. And most of Asia uses metric too. So that's smart. So, and Canada. If you ever been to Canada, like everything there is done in metric. We're one of the few holdouts, and there's really no good reason for it, except that we don't like it because we're not comfortable with it. We're not used to it. So like, I think I told y'all before, but sometimes I'll go to order something on Amazon and it'll give me the measurements like in centimeters. And I have to ask, who over here or my phone or whatever to convert it for me because I can't visualize it very well. Even though I teach science and I work with metric all the time, it's still hard for me to visualize because I don't do it every day, right? So it's much easier though to use the metric because we talk about how it's base 10. All right, so somebody give me these again. What is king stand for? What's the K, Annabelle?
Kilogram.
Kilo, or yeah, kilo anything, kilogram, kilometer, all of that, right? And that means 10 times 10 times 10, or 1,000 of your unit. So if your unit is meter, 1,000 meters is a what? What's it that is a kilometer, right? Yeah, we tend to say kilometer. But yes, 1,000 meters is a kilometer. So if you go to Canada, their speed limits aren't in miles per hour, they're in kilometers per hour. Uh-huh.
And one kilometer equals 1 kilometer equals 1.5. I mean, 1 mile equals 1.5 kilometers.
Thereabouts. Yeah, thereabouts. So when you go to Canada, the speed limits, they look higher. Like the numbers are higher. So like our 55 is like 90 something or whatever when you're there. So you see it and you're like, "Ooh, I get to go 90 something? No, you don't really. You get to go what you're used to going, 55 miles per hour, but instead it's kilometers per hour. So there's that. All right, and then, oops, they're moving along. Whoop, gosh, okay, kilo, and then what's the H for? Okay, Lucy, hecto, very good. How about the, what do we say for diet, Emerson? Deca, very good. And then the U is, what's the U, Everly? Unit, and then what's this drinking for, Annabelle?
Decimeter.
A deci, yep, and then what's the C, Emerson? Centi, and then what's the last one, Lucy? Milli. All right, very good. So how many decimeters are in 1 meter? Who knows? Eunice.
Negative, I mean, 0.10.
There you go. Yeah, or 0.1.
0.1.
How many decameters are there? Uh-huh.
10.
Okay, there you go. So the other way around. So there's 10 decimeters, right, in a meter, right? And then there 10 decimeters in a meter, right? And 10 meters is a decameter, right? Okay, there you go. So then when you look at a ruler, like we have metric rulers today for lab, and you've got your centimeters, and then inside you have, what's inside the centimeter? What's the next measure inside? Do you know what's inside of them? Like when you look at it like this, you have, seal this one.
Inches.
Here's your centimeters. What are these little marks inside the centimeter?
Millimeter.
Those are millimeters, right?
I did this in
So 30 centimeters, how many millimeters?
300
300, right. What's on the other side?
inches.
Inches. And we don't put 10 somethings inside of an inch, do we? We do a half inch, then a quarter inch, and then an eighth, and then a 16th, and then a 32nd. Isn't that fun? Why don't we want to convert 1/32, 4 30-seconds, or actually, let's make it real fun. 3 30-seconds of an inch is how many yards? Are you ready to be like, no? But
Aww.
I can say, I can do this much more easily. It's still rolling. I don't know why it's rolling. It's not supposed to. Okay, so let me put this back over here. All right. So if you're going this way, you divide by 10. And if you're going this way, you multiply by 10. It's easy because it's tens. All right, so back onto the cute guy. Weight is the effect of gravity on mass. So what varies by location? Annabelle?
Weight.
Your weight can vary by location, but what doesn't change?
Mass.
Everly. Your mass does not change. If I go into space like this little dude, my mass is not going to change, but my weight will change. Why will my weight change?
Because there's no gravity in space.
Well, there's gravity. There's just not
Enough
as much gravity. There's less.
I mean, depending on the size of the planet, like your weight varies on the size of the planet. Like,
Mhm.
a smaller planet might mean you have a smaller weight.
It also depends. Yes, that's true. That can change. That affects things. It also depends where you are in space. So the closer I am to Earth, higher or lower for my weight? Closer I get to Earth, finding higher. The closer I get to Earth, closer I get to Earth, sorry, the heavier I get, right? Because it's Earth's gravity is pulling me towards the center of Earth, and that force gets greater the closer I get to Earth. So if I'm up floating around in space somewhere above Earth, I have very little gravity. But what if I'm really close to the sun? What's going to happen?
You're gonna have a,
What would happen? The sun's really big.
you're gonna have a lot of.
A lot of weight. I'm going to be real heavy, and the
bet-
sun's going to suck me right in, right? Because that's very, very.
But it's impossible to go anywhere.
Yeah, I'd be incinerated before I got sucked in. But hey, you know.
Yeah, hey,
Hmm.
that little guy doesn't have a helmet.
Yeah, he's
Magic rat.
magic rat. Yeah, magic
Well-
space rat.
He got tested on by science and now he can breathe in space.
He's extra special. He doesn't require much oxygen. I don't know. All right, does anybody have a phone today or a iPad?
Wait, oh,
If you have one, you can play. If not, then
it's in the car.
Okay. that's okay, no biggie. We can play without it. All right, question. Where would you weigh more? Denver or New Orleans? Okay. Where's my globe? Here's my globe. Okay, where's Denver? What's Denver's in Colorado. It's right.
New Orleans is in the shoe state.
It's in the shoe state. Here's Colorado. Here's Denver. There's a big mountain range right there called the Rockies. They call Denver the Mile High City because it's about a mile higher than sea level. Okay.
There's the shoe state where New Orleans is.
Yep, New Orleans is in Louisiana and it's right there. Does anybody know? Anybody want to take a guess now? Where would my weight be more?
In Denver.
In Denver?
Your weight would probably be the same.
Who votes for Denver? And who votes for New Orleans? Okay, if you're voting for Denver, why are you voting for Denver?
Because it's a rocky.
Because it's rocky? What do you think? Don't know? Just throwing up a guess. Okay, how about New Orleans? Why do we think, who thinks you'd be heavier in New Orleans?
Because you go up into the sky,
Mm-hmm.
you weigh less.
Okay, the higher you get, the less
And
less you weigh.
Denver, it's high up.
There are.
So in New Orleans, it's low.
Right. So here's the actual thing. So you weigh more in New Orleans because the effect of gravity on your mass is greater, closer to the center of the earth. And New Orleans is very low. So Denver sits at 5,280 feet above sea level, and New Orleans sits negative 6.5 feet below to 20 feet above sea level. So, but here's the thing. We talked about limits to measurement. Remember we talked about limits to measurement? What are limits to measurement? Well, this is where that plays in. If you tried to actually measure the difference, it would be so small. Because although 5,280 feet, although it's at most, or at least, let's say, at the least, 5,260 feet higher in Denver, that's really only a little bit when you're thinking about something like gravity. You're not like off in space, you're just in Denver. So although there is a difference, it's so small that we really can't measure it. That's a limit to measurement. We don't have equipment that's that specific. Also, you would have to travel, right? From Denver to New Orleans. And that's going to take a couple hours even in a plane. And lots of things can happen, like, you might have to go to the bathroom. Well, now you just lost weight. Because there's a little less going on, right? So it's very, very small. So some factors that would limit your ability to get a good idea of exactly how much your weight might differ between these locations. What are some factors? Let's think about it. I just gave you an example. You'd have to go to the bathroom somewhere in between on travel.
Yeah.
What's another problem? Why couldn't you measure this?
Because you would get hungry and you would need to eat, and not eating also like causes weight loss, so.
Yeah.
the
You
whole
could.
Situation.
You could starve or you could eat, and either of those things might change your weight. And then also you'd need a piece of equipment we don't have. We don't have anything that specific. Okay, so mass is how much stuff that is. So your mass does not will not change if the force of gravity
That's up there.
acting on your back. Yeah. So this guy has more mass than this guy. But your mass doesn't change no matter what happens with gravity. So there's as much of you in New Orleans as there is in Denver. Right? Same amount of you, but you might weigh a little different. All right, so what are some ways you can change your mass? Okay, you guys you can't answer on the Mentimeter because you don't have your phones or whatever with you, which is fine. So somebody give me, what's a way you can change your mass? Everybody give me something and try to give me something different. Okay, you want to go first? What's a way? You could lose weight. Okay, you could go on a diet. You could change your mass that way.
Go on a diet.
Anyway,
I also like think like you could like weigh more if like you ate a bunch between now and then.
you could eat a bunch. Okay.
And then like that would make you fatter.
Mm-hmm.
That rabbit has a mohawk.
That's a female cardinal.
That has a mohawk.
Yeah, she has, it's called crown. See her?
But it looks like a mohawk.
It does. So does anybody know about how much a gallon of water weighs? 8 pounds, if we're doing pounds, something that we do. I don't honestly know what it is in metric, but because it's a gallon, so it's imperial to imperial. 1 gallon of water is about 8 pounds.
Sometimes it's
So I knew a guy once who played a trick on his coworkers. They were doing a weight loss competition. Who could lose the most weight in a week was their competition. So they had a day where they all came and weighed in and they wrote everybody's weight down, right? And then at the end of the week, you came back and they weighed you in one more time and there was like money or whatever to win. But this guy played a joke on everybody. Before weighing in, he drank a gallon of water. Now he weighs 8 pounds more. So at the end of the week, it looked like he lost 8 pounds, which is a lot of, if you're losing fat, that's a lot to lose in a week, right? Most people don't lose 8 pounds a week when they're dieting. So he appeared to have lost 8 pounds in that week. He
cheated.
Yeah, he was playing a joke, but yeah. All right, what's another way you could lose some mass? Everly, do you have any ideas? How could you lose some mass? Oh no? Emerson, do you have any ideas? Lucy? Ways to lose mass? You ever had a haircut? Yeah, you lose mass then, don't you?
Or another really weird one, but like I guess another way to lose mass is by cutting off.
Yeah, you could cut off a limb. Yeah, so actually have that here. You could diet. You could even pee, change your overall mass, right? You could pick out. You could lob off a limb. We don't want to do that, but you should. Let's not though. Let's keep our bodies healthy and intact and be sure to pee when you need to pee.
Yeah.
Let's do that. Let's make that a life rule, okay? All right. That's a good idea. Okay. So what weighs more? A kilogram of lead or a kilogram of feathers? Who votes for the kilogram of lead? Who votes for the kilogram of feathers? Well, why didn't everybody vote?
Lead.
I know what you're gonna say.
They weigh the same. Why do they weigh the same? Yeah, a kilogram is a kilogram. It weighs exactly the same. A kilogram of lead and a kilogram of feathers weigh exactly the same.
Like,
Mhm.
how much lead or how much feathers?
Well, that's the next question. Which is going to take up more space? A kilogram of lead or a kilogram of feathers? Feathers? Feathers?
Because the lead doesn't have a plural.
The lead doesn't what? Have a plural? Okay. A kilogram of lead or a kilogram of feathers. All right. About how big do you think a kilogram of lead would be? Like with your hands?
Like in a pencil?
In a pencil? Be a little bigger than that. It'd probably be about,
I forgot what lead looks like.
like so maybe.
I forgot.
A small apple, maybe a lemon. You could probably get a kilogram of lead that way.
I don't like one.
Sure, that's not, yeah. And then a kilogram of feathers would probably be, a good sized bag, depending on how much you packed them in. All right. So when we're talking about taking up space, what unit of measurement what type of measurement are we talking about?
Volume?
Volume, right, exactly. So what has greater volume, a kilogram of lead or a kilogram of feathers? So
Feathers.
kilogram of feathers is going to take up much more space. And here's why. It's density. Okay, lead is far more dense than feathers. By dense, I mean how much matter is taking up that given volume. So lead, all the molecules in the lead, they're all real tight together, right? And there's lots of them and they're packed in tightly and they're heavy. And then feather, if you really looked at a feather, a lot of that structure is very spread out, right? It's all kind of wispy and it's like a lattice and it's all spread out so that you've got greater surface area, but it's very lightweight. Have you ever noticed that birds have different kinds of feathers in different places on their bodies? What do you notice about it, Emerson? Some have more feathers on their wing. What kind of bird would you suspect would have more feathers on their wings?
Turkey.
Like a chicken or a hawk?
A chicken.
Ooh, a hawk, right? Because they have to fly. So birds have little fluffy feathers, the kind that go in pillows. Do you know what those are called? The little fluffy ones that keep them warm. We put them in pillows. It's called down.
Lick them up.
Down. They're called down. They're real fluffy. They're like little tiny fluffy wispy ones, and they're the kind that you put in. They use them for jacket filler, or they use them for pillows. So if we look over there, you can see both my female cardinal and there's a chickadee down there as well. And if you look at the cardinal right there, do you see her tail? You see those big long feathers?
Yeah.
And then if she were to spread her wings, which she looks like she might do in a second here. If she were to spread her wings, you'd also see big, long, flat feathers there. Look at her. She's flitting around.
Wait, how do you know what feathers, what birds they're?
I just know my birds.
You need to do yours. Yours.
Well, I don't own them, but
I
I
have a
just
bird book at
I also
home.
have this amusing bird book. I have two bird books. I have a serious one and a funny one. My serious one's a little green one over there, and that's the Audubon Society book I got from my grandmother. This one is called The Field Guide to Dumb Birds of North America, and it's a funny book, but it has, like, for example, some of these I can't read. Because they're not very, here, Western Wood Pew Pew is what they're calling this one here. That's not what it really is. But they're all funny in here. Like, they're funny names for the birds. So some of them are not very nice name. Like Scarlet Tanager, they're calling it a scarlet teenager.
Find the bull.
Scarlet.
Yeah, so those big long feathers that are on their wings that help them fly are called pinions, and they're flight feathers, and they're very different from the down. But in either case, they're nowhere near as dense as lead. Do you know, have you ever looked at, you ever gotten a feather that's like a quill type feather
Yeah.
and noticed that the quill is hollow?
Yes, in the 1920s.
Yeah, okay, yeah. Do you know that a lot of their bones are also
Wait, no,
hollow?
the 170s.
Did you know that? A lot of bird bones are hollow? Why would they be hollow? Why would a bird have hollow bones? What do you think?
There's space inside.
Yeah, and think about density.
Yeah, there's that.
It's far less dense, and what does a bird need to do? Fly. So if you're very dense and very heavy, you have a lot of mass, and there's a lot of gravity pulling on that mass, you're not going to be able to fly as well. So a lot of birds have hollow bones that help them fly. You got less density. We have hollow bones too. Our long bones are hollow. So that would be like your femur, your tibia, your fibula, your humerus, and your radius and ulna are all hollow bones. But inside we have like marrow and stuff, and that's where we produce blood cells and things like that. But those are like Ozzy has one over there that if it's hollow inside, the bone is hollow inside, and that's from I think a tibia of a cow. Ozzy's in his crate.
Yes.
Oh, wait,
Yeah.
can I ask a question?
Yeah,
So are we just never gonna get to pet Ozzy again?
quite possibly. Yep. I can't risk that. It's not that I don't trust him, but that's not a risk I'm willing to take. So bad things happen to dogs that have
I mean,
issues.
has that
So-
even ever happened before?
But it's okay. It's no big deal. He likes it in there. That's his home and he is happy in there. He puts himself to bed in there. That's his place. That's his home. And it is absolutely fine for him to be there. So no worries about it at all. Yes.
Can I answer the next question?
Yes. So density, how much mass there is stuffed within a given space or how much mass per volume. Density is given as what?
Mass divided by volume.
Right. Mass divided by volume. So density is a math problem. How much mass is there within a volume? And remember that volume is given as either like liter as our unit, or you can also do centimeter cubed. You can do centimeter cubed. and get volume as well, because it's length times width times height, right? All right, so mass divided by volume. So considering, here we go, considering that density is mass divided by volume, will the density of a substance change if the space in which it is contained becomes smaller? What do we think? Yes or no? Will the density change if the space in which it contained is smaller? So the first thing you have to know is the space in which it is contained. In that math problem, D equals M divided by V, density equals mass divided by volume. What is the space in which it is contained? What part of that math problem represents those words? Do
It
we know?
will change it.
It'll change, you think? But what part of the math where it says the space in which it is contained? Where in that math problem do you see the space in which it is contained?
Oh, like in that lava lamp, if the lava lamp portion for some reason shrink.
Yeah, that's what I'm
shrinks,
asking. If it
yeah.
shrinks, does it change the density? Okay, so.
Yeah.
What is the space in which something is contained? What do we call that?
Dense, volume.
Volume. Very good, Eunice. So. When you read a problem like this, you have to be able to translate those words into the math problem. So where you see the space in which it is contained, you have to go, that's volume. So what this problem is asking is, considering that density equals mass divided by volume, will the density of a substance change if its volume shrinks? So what do we think? Considering that, so you have a multiplication problem. Let's pretend for a minute that M is 3, okay, the number 3, and V is the number 2. Oh, no, let's not do that. M is 4. Hang on, let me make M bigger. N is 10. Let's pretend that M is 10, okay? And V is 2. What's 10 divided by 2?
5.
5. Okay. So now let's do an experiment. Let's change V, because we said, will the density change? So in this case, D would be 5, because M divided by V, 10 divided by 2 is 5. Everybody agree? So if we took that V and made the V different, let's make the V 5. Now what's 10 divided by 5?
2.
Okay, so did it change
Yeah.
the answer? Yes. So anytime you're multiplying something by something else, your answer is going to change if one of those numbers changes. What's 3 times 4? 12. What's 3 times 5?
15.
What's 3 times 2?
6.
6. So anytime I change that second number, then the answer is different, right? So if you're multiplying 2 numbers and you change one of them, it's going to change your answer. So yes, if the density of a substance is going to change, if the space in which it is contained or its volume becomes smaller. So any change to a substance's mass or volume is going to affect its density. So mass and volume and density are all interconnected. So whenever you see things in a multiplication problem like that, they're all interconnected. All right, density of water. How do we do density of water? What's it given as? Do we know? Anybody know? Do you know, Annabelle?
Liquid.
Yeah, it's a liquid. Well, it can be. It can also be a vapor or a solid.
Yeah.
But what's the density? Eunice, do you know?
1 gram divided by centimeter cube.
Yeah, so it's a gram per milliliter or a gram per centimeter cubed. Okay, this is the other great thing here about metric.
Miss Danny,
We're able, yeah.
I have a question.
Mhm.
You said 1 gram per centimeter cube, but it says 1 gram divided by centimeter.
That's the same thing. So per means divided by. Yep, so per and divided by mean the same thing. So always keep that in mind. So if you have 1 gram per milliliter, that's the density of water. You can also say it's 1 gram per centimeter cubed. So what does that tell you about a centimeter cubed and a milliliter? What?
So 1 gram is probably mass and milliliter is probably a volume.
Milliliter's definitely a volume.
And
But
one
if
gram
you
is-
know that 1 gram per milliliter is the density of water, but the density of water is also 1 gram per centimeter cubed, what can you tell then about a centimeter cubed and a milliliter? What?
The milliliters for water and centimeter cubed is for something else.
This is both a big, so a milliliter is equal to a centimeter cubed. And you can tell because I'm telling you that water is 1 gram per milliliter, or you could also say 1 gram per centimeter cubed. So did gram change? Did how many grams change?
No.
No, the grams didn't change. But if your milliliter and your centimeter cubed are both, they're the same. A centimeter cubed, a cubic centimeter, which is a centimeter times a centimeter times a centimeter, is the same volume wise as a milliliter. Again, this is why metric is so good. All right, let's have a look here. All right, who can do this one? Convert 2 milliliters to cubic centimeters. Think about what I just told you. 2 milliliters to cubic centimeters.
2 milliliters.
And your answers are here, your choices. 6 centimeters cubed, 2 centimeters cubed, or 0.2 centimeters cubed. What do we think? Okay, so look back here. 1 gram per milliliter is the same as 1 gram per cubic centimeter. All right, so who thinks it is 6 centimeters cubed? Anybody want to vote for that? Nope. Who thinks it is 2 centimeters cubed? Who wants to vote for that? How about 0.2 centimeters cubed?
Alright, I'll go for 2 centimeters.
Okay, so 1 milliliter is equal to 1 cubic centimeter. So 2 milliliters is equal to 2 cubic centimeters, right? That's what we were just saying. A milliliter is a cubed centimeter. 1 centimeter times 1 centimeter times 1 centimeter is the same volume as a milliliter. So 2 milliliters is 2 cubic centimeters. And notice right here, what's meant by this little caret here, that little up-shaped V?
Up-shaped V's power.
Yeah, that's how we have to type it in Teacheries and also in Mentimeter, but it's an exponent. It's showing you that that's an exponent. It's cubed or squared. So that's why metric is so darn nice, like I was saying. So you can easily say 2 milliliters, which is a unit of volume, right, is 2 centimeters cubed. Same thing. All right, so now convert 6 tablespoons to pints. Yeah, that's the answer, 0.1875. This is why we use metric in science. What was easier, converting 2 milliliters to 2 cubic centimeters or converting 6 tablespoons to pints? Yeah, that's not fun. Tablespoons and pints? Look at that. That's crazy. So that's why we don't love that
Who
in
can
science.
someone that's double jointed?
Oh, I know my best friend is. Yep.
I know a YouTuber that's double jointed.
Okay, well, let's stay on topic. So who can give me, I think this is in your notes. So who can give me a definition for International System of Units? You want to go for it?
The International System of Units is a modern form of metric system, and it is used almost every country.
Yes, and it's a system that scientists use to measure the properties of matter. And we call it, it translates to the International System of Units, or SI units. Why is it not IS units? Because it's actually, that is an English translation, international system. It's actually Système International d'Unité, which is French. So SI comes from Système International. That's where we get it. Yes. So how about mass? Who wants to define mass? Everly.
The amount of matter in an object.
There you go. The amount of matter in an object or a substance. All right. Who wants to give me volume? Emerson.
The amount of space matter.
Right. The amount of space an object or matter occupies. Density. Lucy.
Is a measure of the mass of material in a given volume.
There you go. It's an object's mass divided by its volume, or its mass per unit volume, or the amount of mass within a given volume. Very good. And then how about weight, Annabelle?
Okay, Sorry,
You're fine.
where.
See if you can do it without looking at it. Let's
Uh,
wait.
It's the amount of
Is the force of,
force of, how much something weighs.
yeah, it's the effect of the force of what? Gravity
Gravity.
on an object's mass, right? Force of gravity on an object, a measure of the force of gravity. Okay, so you had this in your work. All right, your first question was, what's the volume of this little block, this solid figure? Be sure to use correct units of measurement. Lucy, what'd you get?
150 centimeters.
And how did you get that?
Because
10, not what the X was, and
Times.
times
Uh-huh.
5
Yep.
times 3.
Yep.
Is 150.
Very good. So that's what it is. It's 10 centimeters times 5 centimeters times 3 centimeters. So it's 150 centimeters cubed to the third power, right? Because it's centimeters times centimeters times centimeters. So 3 centimeters, centimeters cubed. All right. The solid has a mass of 180 grams. What's the density of the solid? Who's got that one? Lucy again? What'd you get?
Oh, that's math was.
Oh, you're not sure? Anybody else want to give?
It was
Oh, wait.
180
Okay.
and 150,
Mm-hmm.
and the answer is 1.2.
Yeah, you get the right idea. What was the operation? 180 grams per centimeter cube. So it's mass divided by volume. So your mass is 180 grams divided by 150. Yeah, 150 centimeters cubed. So remember that you give density as grams per centimeter cubed. See it? Because you didn't change. As long as you're not canceling out your units, you have to keep your units always. All right. So would the solid have a mass of 180 grams? Yes, it's just a cardinal. Would the solid have a mass of 180 grams on the moon? Would it have the same weight on Earth as on the moon? Explain your answers. Okay, Everly, what you think?
Is that a ball?
Might be. Go ahead, Everly. What's your answer?
Right, the second one is wrong.
Okay, so the first one is right. The second one is wrong, she says. So the mass would be the same on the moon, but the weight is going to change because the force of gravity
Yeah,
changes.
it's gonna be lower.
Mass stays the same no matter where you are. All right, number 4, the solid sinks to the bottom when placed in a container of water. What does that tell you about its its density?
I found a brownie point. It's not black, it's white.
Oh no, it's just there's a it's cut off, like the image got cut off. Okay, Emerson, what do you think?
It's more dense.
It's more dense than the water. That's exactly right. So it's greater, its density is greater than 1 gram per centimeter cube, because 1 gram per centimeter cube is the density of water. So will every solid with the same dimensions have the same density? Annabelle?
No, no, because it could like be bigger, like, this, if like, this was a little rounder, it would be like, it would be like, a sphere, but it's still not as big as that, but even though they're both
Right.
3D.
Okay, anybody else want to add to that? Emerson?
They could have different mass.
That. There you go. Exactly. So you could have the same dimensions, but have a different volume because the mass is going to be different. Because remember, your density is your mass divided by your volume. And if you change the volume or the mass, it's going to change your density. So although a shape with the same dimensions would have the same volume, if it were made of lead or if it were made of foam, you would have a very different density, right? Would foam have more or less mass than lead?
Less.
Far less, right? So, all right. There's also, have you ever seen, I should have put it in here. Sometimes I remember and sometimes I forget. Anybody ever seen the Monty Python Quest for the Holy Grail? No? So there's a scene in there, it's a comedy. But there's a scene in there when they are talking about, they caught a woman and they say she's a witch and they're trying to determine whether or not she's a witch. So they're gonna throw her in the water and see if she floats. And they're asking about what things float in water. And one guy says, a rock. Does a rock float in water? No.
One thinks why.
And one of them was wood. And yes, wood usually floats in water, unless it becomes waterlogged, wood usually floats in water, right? Because it's less dense in the water. And then they come up with a duck. Oh yes, a duck. And they get in this whole, they go back and forth with this whole thing. And then what they do is they have scales. And they put the witch on one side and they put a duck on the other side. And the duck weighs more than the witch, so they decide she's a witch, and she's not. But it's a funny movie. If you like old British humor, all the Monty Python stuff is good.
So, witches do not practice magic, they practice witchcraft.
There you go. Just not the same thing, is it?
Chick.
There you go. Unless you're a Harry Potter witch, in which case, yeah. All right, so what I need y'all to do is I need you to get out your, go ahead and get out lab 3 from last week. Hang on to it. And lab 4. And hold on to both of them for me for a minute.
You get the whole afternoon or just the separation?
Just the, actually, just get to the page that you're turning in, page 910. Some of you don't have it because you left it here. If you can't find your lab 3, it may be in lost and found by the front door, because some of you for sure left it here.
But Liam's is in class.